Hey everybody, this video lesson is going to cover the steps for naming acids and bases. Acids are considered ionic substances but have a specific naming scheme associated with them, so they're just not like normal ionic names, but you will use the ionic name to figure out the acid name. There's basically two steps for naming acids. The first step is write out the name of the ionic name of the acid. For example, HBr is hydrogen bromide. Now that you've written out the ionic name, use the acid naming chart to find the acid name. Now, the acid naming chart is located on the back of your periodic tables, in the bottom middle of the table itself. There's a little table, and it looks a little bit something like this. This chart has 2 anion endings. Yours on the back of the periodic table has 3. The one that is on the back of the periodic table has an OUS ending as well, but we are not going to worry about that. So don't worry about the OUS ending. These are the two that we're going to work with most of the time. If the anion is IDE ending, then you use this name. You write out hydro, the root or the stem of the anion, and then add an IC on the end. Now if the anion ends in ATE, like carbonate or acetate or sulfate, then you simply just write out the root of the anion again with an IC. Notice, 8 has no hydro in front. Ides are typically monoatomic, which means that they come from the front of the periodic table, where 8 endings are typically polyatomic, which means that they come from the back of the periodic table. Now there are a few IDE endings that are on the back of the periodic table, but not many. Most of them are ATE endings, and of the 8 common polyatomic ions, most of them, 6 of the 8 were ending in 8 or ATE. Here's a couple of examples from our notes, and I've blocked out the answers so that we can't see them, but we'll work on them together. The first one is hydrogen chloride. Now since it ends in an IDE ending, that means that there's a hydro in front. If it were an ATE ending, there would be no hydro. So we start with hydro, and then the stem or the root of the anion is chlor, and then add an IC and then acid on the end, hydrochloric acid. The next one is hydrogen sulfate. Now because we have the ATE ending, I know I'm going to need to write out the stem of the anion without the hydro in front. Remember, 8, no hydro. The stem of sulfate is sulf, so I'd write sulfic acid. And actually that's not the real name because there's a couple of stems or a couple of roots of the anions that change a little bit. Sulfur is one of them and phosphorus is the other one. Technically the name is called sulfuric acid, but if you wrote sulfic or sulfuric, I'd give you credit. But as long as there's no hydro on the front because the polyatomic ion ends in ATE. Now along the same lines of logic, you should be able to take the name of an acid and translate it to symbols. The key here is to balance charges. From the name of the acid, you should be able to determine the anion, and then you're going to put hydrogens out in front to balance the charges of that anion. For example, hydrobromic acid, hydro means that it's bromide, or just Br. Then you're going to put a hydrogen, which is a +1 charge, for every negative charge of the anion. Rewrite it without the charges on top, and it's simply HBr. The next one is called carbonic acid, and since there's no hydro, it must end in an 8. Carbonate is CO3 minus 2, and I'm going to put 2 hydrogens in front, each of which is a +1, to balance out the -2 of the carbonate. So I rewrite this as H2CO3 without the charges. These last couple are practice problems that you can do in your notes, and I'm going to go through the answers right now. This first one is hydrogen phosphate. Translate that to acid name, it's phosphoric acid. Again, no hydro because phosphate, 8 endings have no hydro. Going down, again I have hydrogen carbonate. 8 ending, no hydro. The name becomes carbonic acid. Number 3, hydrogen fluoride. IDE ending has a hydro in front. Hydrofluoric acid. Number 4, which is what I'll write over here, is hydrogen chlorate. ATE ending, no hydro. The answer here is chloric acid. This next one is pretty tough. In fact, Cn is not one of your 8 common polyatomic ions, but it is a polyatomic ion. That is indeed cyanide. Cyanide ends in IDE, so you go with typical naming rules for naming this acid. It is hydrocyanic acid. And finally, number 6, hydrogen iodide. So it's hydrogen iodide or hydroiodic acid. Same thing, do these in your notes. These are going from words to symbols. Probably the tougher of the two. First one, nitric, has no hydro, so it's nitrate, NO3 minus 1. Put a hydrogen in front, you've got HNO3. Next up, another one without a hydro in front, so it's acetic or acetate, which is C2H3O2 minus 1 charge. Again, put one hydrogen in the front to balance the charges. This next one has hydrobromic, so it's just Br or bromide. Minus 1 charge, put a hydrogen in front to balance charges, HBr. Next one is number 4, and that's this one, sulfuric acid. No hydro, must be sulfate, SO4 minus 2. 2 hydrogens in front to balance the charges, erase the minus 2, and you got H2SO4. Next one is hydroiodic. We just did this one on the last slide, but this one's words to symbols. Hydro means iodide, or I minus 1. Put a H plus out in front, you got yourself the formula for hydroiodic acid. Finally, hydrofluoric. Again, fluoride with a hydro, it's just a -1 monoatomic ion. Put 1 hydrogen in front to balance the -1 charge. There you go. The final thing I want to talk about is naming bases, and there's no special thing for naming bases. Bases follow normal ionic naming rules. And my bases are always going to be hydroxides, at least for regular chemistry. So it's going to be a metal hydroxide, metal hydroxide. Other examples could be CaOH2, calcium hydroxide. Could be AlOH3, aluminum hydroxide. All of them are a metal hydroxide. Those are all bases. Well, that takes care of this video lesson. Thanks for listening.